Good morning. Hello and welcome to 3D Vision Technologies 10-4 Tech Talk, a monthly introduction to engineering technology that can make your company better, faster, and smarter. I'm Todd Majeski, your host for today. Today's topic is improving SOLIDWORKS performance, and our guest speaker is Justin Maxwell, Application Support Engineer Level 2 and a certified SOLIDWORKS expert for 3D Vision. Justin works out of our Cleveland office and has been with our company for over 5 years. In addition to being a SOLIDWORKS certified expert, Justin has a mechanical engineering degree from the University of Akron. Good morning, Justin.
Good morning, Todd. How are you doing?
I'm doing great. So, Justin, before we get started, I'd like to tell our listeners a little bit about what you're doing here at 3D Vision Technologies. So can you tell the audience what a typical day looks like for you?
Yeah, sure. So I'm on our technical support team. So Monday through Friday, 8 to 5 p.m., we're available for phone calls, emails, or even through our SOLIDWORKS website. So my typical day is answering as many questions as I can from all of our customers.
So people typically aren't very happy when they call you, but they usually have really difficult problems.
Yeah, we like to think if you're not happy when you call us, you better be happy when we hang up with you. So
that's a great attitude. Well, thanks for doing that. All right, so I'm expecting many of our listeners have already worked with you in the past, so that's great. So some of you already know Justin. So before we get started, I wanted to at least do a little bit of housekeeping. I want to remind everyone that we are going to have some questions or poll questions, so look for those. And also, if you have questions, go ahead and use that chat window at any time, and we'll get to them at the end of our 30-minute presentation. The other thing I want to remind everyone is that we are recording this, and we'll send you an email following this presentation with a link that you can use and share with anyone or reference for further use. So let's just get started, and let's turn it over to you, Justin.
All right, thanks, Todd. Morning, everybody. Like Todd said, my name is Justin Maxwell, and today we're going to be talking about improving SOLIDWORKS performance. So we actually did this webinar about a year ago, but it was a different version of this. So we've kind of adjusted it for 2017 and made it a little better. So it's kind of a continuation if you saw that one last year. A lot of new information, though. Today we're going to be talking about 3 main things that can improve SOLIDWORKS performance. The first thing is computer hardware. So what changes can you make to your computer itself to improve performance? Large assembly management. So what things can you do within a large assembly? Because again, I'm on technical support. I see a lot of questions every day. A majority of them performance related are large assemblies. And then we're going to finish off with troubleshooting. So some tips and tricks that I've accrued over my 5.5 years of working in technical support, again, of improving performance for our customers. So computer hardware, a lot of people ask what's the important factors in hardware that SOLIDWORKS really cares about. The first thing is your graphics card. Now, SOLIDWORKS has a website that they talk about what graphics cards are approved. Really, as long as you have an NVIDIA Quadro series or an AMD FirePro series, or there's actually a couple others as well, you're usually okay for SOLIDWORKS. Those are our workstation end cards that you can buy from Dell.com or HP.com or whatever provider of computers you use that are not for gaming or anything like that. They're not for personal computers. They're actually geared for CAD and for other workstation applications. That's the most important part in your hardware. The second most important thing is your RAM. Now, when you open up a file, an assembly file, a part file, whatever it is in SOLIDWORKS, it opens it up and it transfers it from your hard drive or from that network drive to your RAM. So if you don't have enough RAM to open up that assembly, you're going to have significant performance issues. Or if you're running low at all on RAM, you're going to see those performance issues. So what we recommend is taking your largest assembly file that you work with commonly, whatever the file size of that assembly is, double that, and that's how much RAM you probably should have on your computer for SOLIDWORKS. Other applications might require different, but that's usually what we go for as a good estimate of how much RAM you should need. And then with the processor, that's a little bit of a more tricky thing to ask. What we usually say is when you're buying that computer from Dell or Lenovo, buy whatever processor you can afford that time. So get the fastest possible one that you can currently afford. There's a lot of numbers out there of what processors do what. Really, SOLIDWORKS isn't very particular in the exact processor that you need, but make sure that it's approved on the SOLIDWORKS website, and make sure that you buy, I guess, the best one that you can at the time.
Justin, can you just comment a little bit about multi-core, just to see if there's any benefit for customers about multi-core?
Yeah, sure. So a lot of people ask about that when they're buying a processor. Should I get a multi-core processor, that has 16 cores, or should I buy one that's only a couple cores and the fastest? I usually say get the one that's the fastest possible. Now, there are some applications in SOLIDWORKS that can use multi-cores, but the majority isn't a significant difference. So maybe if you do rendering or simulation, multi-cores will help you out. But in most cases, just get the fastest one that you can get at the time.
What about hard drives? I know you mentioned about pulling data from your hard drive or the network drive. Mm-hmm. Some people are looking at these SSID drives, which are solid state drives. Is that going to add some speed?
Sure, yeah. So solid state drives are going to definitely improve performance, assuming you put your files on a solid state drive and SOLIDWORKS is running on a solid state drive. That's the fastest transfer rate that's available today. So definitely improving performance there as well.
All right, great.
Now, I mentioned you can go on this website here, and there's a link actually that we're going to send in the chat of GoToWebinar, and it's to the SOLIDWORKS website under their support video card testing page. What that looks like, I'm going to open it here, is we can go into this website, and you can basically select what type of computer you have. So I can select Dell. What driver, what kind of status do you want? We want certified. What computer model you have. So I'm going to slide down here and pick maybe the M6800 popular card that a lot of our customers use. Maybe what graphics card I have in that computer right now. What version of SOLIDWORKS I'm intending to use this computer for. And then what operating system's on that machine. By filling out that info, it's going to give me a driver that's specific to SOLIDWORKS and approved and certified for SOLIDWORKS that's for your computer. So you can download that with that link right there, and then you're good to go.
You mean once it's downloaded, you're done?
Well, I guess not necessarily. Once you download it, then you do have to install the driver. So, yeah, no, if you just download it and it's sitting in your recent downloads folder, that's not going to do much. But once you install it, then you're good to go. All right, and there's actually an easier way to do that whole process by going into SOLIDWORKS and hitting your SOLIDWORKS Resources button. You can open up this tool called the SOLIDWORKS RX. Now, this is also in your Start menu, but in the RX tool, you can go to Diagnostics. You can load these results, and it's going to do that same thing we just did, but automatically. So it's saying that, hey, I'm on an M6700, and I'm not currently using the latest driver. You hit that button, and again, it's going to download the driver. Assuming you install it, then you are up to good. You're at your latest driver available that's certified by SOLIDWORKS. So this is kind of an automated way of going to that website and making sure you're on the right version.
That seems really easy.
Oh yeah. When we're on technical support and anybody has almost any type of performance issue, this is the first thing we do because it is really easy. And then you say, hey, your graphics driver is out of date, and probably 50% of the time, that little click, that download, fixes the issue.
Download and install.
Yes. All right, so let's say you're buying a new computer and you want to choose what kind of hardware. Now, we know the graphics card is a pretty big important thing, but there's a lot of other decisions you have to make when purchasing a computer. Here at 3D Vision Technologies, we like to be the destination that you contact for these kind of things. So if you are going to be purchasing a new computer, I would suggest calling us here at 3D Vision, either in technical support or whatever sales rep you currently work with, and they'll get you in touch with somebody that can probably have some decent recommendations for you hardware-wise. There's also an Intel workstation configurator, which I'll show you here in a second. That's a website. Again, it's another link that we can send in the GoToWebinar software. It should be up now. That's another website that you can go on that will actually walk you through a process of deciding what kind of hardware you're going to want. And then also the SOLIDWORKS forums is an amazing resource for this. There's users out there that are publishing their actual research to SOLIDWORKS and saying this processor works great, this processor doesn't work so great, or anything else hardware-wise. So that forums is an amazing resource for a lot of our customers to take a look at what other users say in those regards. So that workstation configurator, I'm going to open that up real quick and show you how that works. And remember, your PC is only as fast as the slowest component that you buy. So don't just think you can throw in a great graphics card and everything else is fine. Make sure that overall your computer is overall good. Also, good hardware does not replace good modeling. So what that means is if you buy an amazing, perfect machine, that doesn't mean that you can have somebody that's doing bad modeling practices and you're still going to be okay. So in that workstation configurator tool that we provided the link to, you can actually just look at what kind of workflow matches your work's workflow. So do you do 2D and 3D basic design? Do you do advanced design and some basic simulation? Or do you do advanced simulation and rendering inside SOLIDWORKS? In this case, I'm going to say we do advanced design, and then it shows some workflows. Do you work with not very complex parts, very complex, or extremely complex? Let's say we work with the midline complexity with some simulation. We click on that, and then Intel is going to give us a configuration that it thinks is appropriate for your use of SOLIDWORKS. Now, this is from Intel, but they do work with SOLIDWORKS and all this stuff. So if you followed this criteria, you're going to be perfectly approved and good for SOLIDWORKS use. And you can see at that bottom, again, that hard drive, always recommended an SSD, a solid state drive, as your hard drive.
So Justin, would you recommend that customers use like the worst case for their typical configuration? Like let's say once every 3 months they will deal with very large assemblies, but on a daily basis they're typically dealing with maybe 50-part assemblies, something of that nature.
Yeah, I mean, it depends. If whatever your normal ritual day-to-day process is, that's probably what you're going to want to do. There's going to be times that you're working with something that's above your normal workflow, so that's just something you'll have to adjust to at that time. You're not going to want to have a supercomputer when you don't need one, but when you do need one on a day-to-day, you're going to want one.
Yeah, got it.
All right, so we're going to pop up a poll question here for everybody to fill out. We're just interested in your feedback. What areas do you see the most performance issues within SOLIDWORKS? So do you see a lot of performance issues in part files when you're just modeling parts, in drawing files, so making the drawings itself, or assembly files, or maybe all of the above? Go ahead and fill this out for us.
Yeah, this will be interesting to see where most people are working, because we do have customers that are just doing part modeling and they're not really making big assemblies, maybe a couple of parts. You know, we have some guys doing tooling and might just be doing complex, but it looks like we've got everything kind of, let's get the results out here and see what that looks like.
All right, so the results show that most issues are with assembly files, and that's definitely what I would expect. Being in technical support, people call in, and like I said, a majority of them are performance issues associated to assembly files.
Let's not ignore the part files too, which is number 2. So my guess is it could be some complex features, and we can probably talk about that a little bit later.
Sure, definitely. All right, so getting in gear of large assembly, as you said, a lot of your issues are related to assembly files. Let's take a look at some things you can do within large assemblies to improve your performance. Now, first of all, what is a large assembly? A lot of people think it's a number of components that you have to hit, and then you're considered a large assembly, or maybe it's something else like that. In this case, what I'm going to say is a large assembly means that you're using all of your system resources. So common large assembly problems are opening, rebuilding, rotating, anything listed here. If you're seeing any of this stuff, you're working in a large assembly for your environment. So you're going to want to take a look at these tips and tricks that we're going to have about some modeling practices you can do, as well as other things you can do to improve your performance. So as I said, modeling practices. What's the best way to combat large assembly issues? This is something that I see all the time, and sometimes it's hard to do after you're seeing the performance issues, but modeling practices is the key to having efficient assembly files. And that goes all the way down to the part files as you build, and it trickles all the way to the drawings and the assemblies that you're building out of those parts. So in part files, you're going to want to make sure that your orientation's correct. You're using the origin when you can, right? You're not building off in space away from that origin. You're using as simple of features as you can, right? So don't do a sweep when you could do an extrude. Limit any in-context relations. So you don't want relations to other parts when you don't need them. Don't have any circular references at all, and this will pop up a warning if you do get in that situation, but you definitely don't want that. That's like a no-no for sure in SOLIDWORKS. And then whenever you have the chance, if you're building a very detailed part and then you're throwing that part into an assembly file, try to create simplified versions of that part file. It's easy enough to create a configuration and get rid of fillets or get rid of chamfers that you don't need, or at least just simplify it up a little bit so there's less faces and less issues for SOLIDWORKS to work with when it gets to the assembly. When you get to the assembly, make sure you use sub-assemblies as much as possible. You have an appropriate level of detail, so you don't want to be able to zoom in and see nuts and bolts on a huge assembly of a factory plant. And also, make sure you use efficient mates. So don't make something parallel and then put a distance mate between those parallel faces. The distance mates will take care of it. So know what mates do what and don't duplicate everything you do. We see that a lot. Most part files in assembly only need 3 mates to fully define them. So if you've got 7 or 8, you're probably doing things a little bit out of order. And then after you do all that stuff, in the assembly you can actually reduce your memory load on SOLIDWORKS by using lightweight components, using simplified configurations of that assembly, using speed packs when necessary, and then always using large assembly mode when you have the ability to as well. So what are those things? Lightweight components is the easiest way to start improving performance on assemblies. They only load a limited amount of information into memory. So basically it's not grabbing the entire part file when you tell it to load this specific component. It's only loading the graphics and whatever is necessary for the assembly that you're currently in. So this is really easy. You can just right click on a file and set it to lightweight, or a lot of other things actually automatically do this. So most people don't even notice when things are lightweight because it just happens in the background and there's just this little feather icon that pops up on your part icons in the feature tree. Large assembly mode is something that can turn on or off based on your system preferences. So if you say, whenever I have an assembly that's over 250 components, I want large assembly mode on, then it actually automatically does certain option changes, again, to improve performance of that specific assembly. So here's an example of some of those that automatically get turned on or off based on just having large assembly mode on. Speed packs are kind of what I call a super lightweight component. So it strips away the entire feature tree and also a bunch of the geometry as well. So speed packs, you can notice when you have speed packs because as you move your mouse over it, you have this ghosting around your mouse and you can see through things that are speed packed. That's something that means SOLIDWORKS doesn't care about all that other information except for the specific faces that you tell it that you need in that assembly. So let's say it's a part that has a certain face that you're mating onto something else. The rest of that part doesn't matter. So SOLIDWORKS just loads the graphics of it, but that face that you're mating to something else stays intact and it's available for selection, anything like that. So to do that, you just right mouse button on, again, a component or the configuration and say Add Speed Pack, and then you just select what faces or bodies you need to still be selectable when everything else turns transparent. Now a big tip here at the bottom is speed packs are not updated when you make changes to the assembly. So you would have to make it lightweight or turn off that speed pack to get changes to occur in those files. It's graphics only. And then the biggest thing you can do to improve performance, and this is if you have a huge assembly that you're not actually making direct edits to, but maybe you're measuring or doing cross sections of it, maybe making a walkthrough of a factory floor, right? That's a huge assembly that SOLIDWORKS is really never going to be able to load quickly. So use something called Large Design Review. That's an option in your File Open menu, and it basically only loads the entire assembly in graphics only. So everything's speed packed basically. The nice thing about that too is you can say I want to selectively work on these certain components in that large assembly, and you can selectively open those parts in context of everything else, but everything else is still graphics. So you're only loading the certain things you're going to make changes to. So this opens assemblies that take 30 minutes in 2 seconds. It's amazing how fast this Large Design Review works. All right, and now we're going to have another poll question. It's going to pop up. So within large assemblies, what issues do you see most often? Do you see issues when you're slow to open assemblies, slow to zoom or move around assemblies, or slow to save assemblies, or maybe all of the above?
I bet each of these answers have their own little workflow that you could answer.
Definitely, yeah. Now we see these 3 examples all the time. We see more examples, obviously, in technical support, but these are kind of the 3 main things. When I hit save, I sit and spin, right? Or when I hit open, I sit and spin. Sit and spin's our tagline of that little cursor doing the little rotating symbol.
Oh, I thought it was the little toy that you give your 5-year-old.
Oh yeah, that is a sit and spin, isn't it?
That's right.
All right, so it looks like everyone, majority of people say all of the above, which I would say, I think if you're having performance issues with assemblies, you're probably seeing a little of all of this, I would say, so that makes sense. So let's get on and see what can you do to troubleshoot this stuff, right? So some troubleshooting topics. The first thing is if you're seeing slow opening, what can you do? You could have low memory, so maybe upgrade your RAM. You could have a bunch of files that are of an older version, So you want to get those upgraded. You could be rebuilding during open when you don't have to, so that's an option. Or it could be related to your network speed. So if you're opening something over a network, it could be taking a while to transfer to your computer. If you have slow graphics, so you're trying to zoom in and out and it's being slow, here's some things you can look at for that category. You could, again, have low memory. You could be at too high of a resolution. Your assembly file could just be too detailed in general. You have too many components in it. Or your graphics driver from that first slide could be out of date, and you're going to want to upgrade that.
When you say high resolution, are you talking, or I mean memory, are you talking about memory on the graphics card or memory on the computer?
That's specifically memory on the computer, so your RAM, again. That's something that's easily upgradable. We almost recommend it to anybody that's having performance issues that we see has lower than required RAM, because it's kind of a cheap addition to most computers. And then if you're having slow saving, you're going to want to look at, again, your network speed. How many files are you changing in that assembly? So if you're changing everything and then saving it, that's going to slow down the saving process. So maybe only do things in chunks, right, as you go. You could be running out of memory, again, so RAM. And then you could be rebuilding and then saving, which, again, is going to slow down the process because you're waiting for that rebuild. Again, that's an option inside SOLIDWORKS. So if you notice that network speed was one of those ones that go across all three of those categories. Network speeds are something that we see all the time that causes an issue. Your connection to a server and transferring that can slow down the process of opening or saving. What we recommend is actually looking at PDM Standard, which you might actually already own if you have SOLIDWORKS Professional or Premium. So if you have Professional or Premium, definitely look at what PDM can do for you right now. There's another link out there. That's our PDM spec sheet, or data sheet that you can download and look at to see what PDM does and kind of a general idea of it. We're not going to get too deep into PDM because that could be a webinar all in itself, but it's definitely something you're going to want to look at if you're a little concerned about network connectivity or speed. All right, so one more poll question here. I just want to know, what version of SOLIDWORKS are you currently using? This might not be a decision that you make, but I'm just interested to see, what version our users are using that are in these 10-4 Tech Talks.
Yeah, I think it's going to be, I don't know the answer yet, but I think it's going to be all over the map. I think a variety of customers or, some of our smaller clients jump on 2017 as soon as they can, but some people like to stay on for, maybe over a year once the release comes out. So I think it's going to be all over the map. Oh, kind of is.
Yeah, definitely looks like it's across the board. A lot of people are upgraded to 2017. That's great. Now, I mentioned that PDM Standard that comes free with Professional and Premium. That's only with 2016 and 17. So that was a new addition in 16. So if you're at 2015 or older and you're looking at maybe possibly getting PDM, definitely upgrade to 16 and then have those conversations with 3D Vision. We can help you through that process. So here's some troubleshooting tips that I have for you. The first thing, again, it goes back to that version thing. What version of SOLIDWORKS do you have? Also, what version are your files at? A lot of people have legacy files that are still in 2014 or 13, and they're opening up these 2016 or 17 assembly files. That's loading all those old versions of components. When you do that, you go through a conversion process every time you open your assembly. So SOLIDWORKS is sitting there, it's converting all your components to the newest version. That can significantly slow down open time. And that's specific to opening times. Once it's opened, you're usually good. But make sure once it's opened and it's converted that you save all those components so they're now at the new version. Because if you don't, and you keep all those parts sitting there at the older version, you're going to have a problem. Also, complicated features can slow down part files, which again trickles all the way up to the assembly. So what can you do to maybe try to reduce that impact on your part? One thing here you can do is, if I look at this model that I created and I go to this tool called Performance Evaluation, it lists all the features in this part and how much time they take to rebuild. So this part in general takes 3.42 seconds to rebuild. That's a lot of time when I'm adding new features. So by going into my system options, I can enable something called the freeze bar. By turning that on, it's kind of like the rollback bar, but it's a yellow bar at the top of your feature tree. So if I go to the top of my feature tree on the left, and I grab this yellow bar and drag it down, what it does is it freezes all the features that are above it. So you can see that little lock symbol. That means SOLIDWORKS is only loading those as graphics. So if I go back to my performance evaluation, and I look at my rebuild time, I'm down to 0.02 seconds of rebuild time. So that's a significant change, and now you can make changes like I could maybe take that 12-volt text, wrap it onto that surface, and I don't have to worry about the rebuilding of all those features above it in the tree every time, slowing me down. So that freeze bar is something that's very nice when you're working in part files, and then again trickles down into the assemblies and drawings. Also, your resolution and detail can cause graphic slowdowns. So all your part files and assembly files, you're going to want to look at this. That resolution detail can be changed. So we have Windows Explorer on the left here and SOLIDWORKS on the right. And you can see I have an assembly open that's 35 megabytes. If I go to Tools Options and I just make a simple change in my document properties image quality, and I slide this little detail slider down, this is our draft, or this is our resolution. It basically makes like circles less circular. Once we make that change and I save this file, that goes from 35 megabytes down to 3.5 megabytes. So that's a 10-to-1 ratio of file size by just changing that little graphic slider. And most of the time, that's not going to affect you as a user. Your drawings are fine. Your assembly still looks okay as long as you're not zooming super far in, and you're a lot better performance-wise.
That seems like a significant impact.
Huge impact, definitely. When I did this test, I was pretty surprised, actually, how big of an impact that was. And then also, to end this webinar, we're going to talk about some options that you can adjust to optimize performance. So these aren't actually options that we necessarily recommend for everybody, but if you're having performance issues, here's some things you can tweak to make it as good as possible. All right? This video is recorded, so if you don't get everything, you can watch it on YouTube. So inside the display style of drawings, you can change all your edge qualities to draft quality. So we don't need those at high quality if we're trying to not look pretty here. We're trying to make it run fast. In performance, we can turn off show contents while dragging drawing views and also the allow updates when opening drawings. So those are some drawing performance changes. In the display of SOLIDWORKS, we can go into that and we can turn off anti-aliasing here in the middle. So turn that to none. We can also display draft quality ambient occlusion. So maybe not as good of graphics, but again, faster performance. In the performance tab, we can turn off the high quality transparency options. Again, something that's not super necessary. The level of detail on our curvature, we can make that less. So again, faster loading. In the assemblies, we can tell it to always automatically load components lightweight. We can make our mate animations off because that's just a graphics slowdown that doesn't serve any purpose. We can turn off update mask properties and use shaded preview. And then we can make sure that no preview during open is on, so that makes it faster for opening times. In the assemblies, we always want to make sure that we have large assembly mode on, so we're going to check that on. And then this threshold here on the right, you can change to whatever is appropriate for you. So right now mine's at 250. In large design review, that's when it automatically opens that graphics only assembly. So that's a high number usually. In large assembly mode, now is where we can check on or off options to tell it to do certain things. So when large assembly mode is on, hide all the planes, don't display edges in shaded mode, don't preview hidden components, optimize image quality for better performance, and suspend all of our automatic rebuilds. So just some general things that can happen in all large assemblies. In the view, what I like to do is just turn off all the transitions. So these are graphics transitions that aren't really necessary. So I just turn all those things off, get rid of the little animations that happen inside SOLIDWORKS to make it look nice, and instead we're going to make it run as fast as possible. All right, then you just hit OK. Those changes are made, and you're basically running SOLIDWORKS in lightweight mode, and you should have as good a performance as you possibly can. Again, I know that was a lot of information in that last video, so you can always check out our page that we're going to email you. On our YouTube channel, we're going to have this re-recorded so you can take down notes if you didn't catch it during the webinar live.
Yeah, and you know what? You're just giving the best of the best, right? And I know there's actually more stuff that you can do. Where would someone learn more about how to do that?
Yeah, so there's a lot of times we recommend looking at our training classes, or we have an advanced training course or advanced assembly course, I'm sorry, that goes over a lot of these things I talked about modeling-wise. So performance of speed packs, large assembly mode, all that stuff is taught in our assembly class. And then another big thing is you always want to make sure that you're starting these modeling practices at the part level. That impacts your assembly, that impacts your drawing. If you're seeing performances later down the road in a drawing, we can probably go all the way back to the parts in that assembly and see things that were done maybe not perfectly.
So where would our audience learn about better modeling practices for part modeling, like, orientation and all those little things that go with a good practices for part modeling?
Yeah, I mean, if you're experiencing issues, I would give support a call at technical support, but also mysolidworks.com is a really good resource with a lot of training things. And also through our training courses like advanced parts and advanced assemblies, we go through a lot of that stuff.
That's great. Okay, there's another question. We just answered a couple of the questions that were on there. There is one more question. What about if the templates or custom property files are located on the network? How can you work that way, local? So let's say the templates and everything's on the network and you're referencing those over the network all the time.
Yeah, that's a good question. So templates are something that actually gets copied to your computer when you use it. So just because you're starting a file and that file is saved on your network doesn't mean that the file now is still on the network. So you're working local when you do a template. So a template's not a major concern. Custom properties, again, is something that's referenced only in isolation, so it's not a huge important factor, I would say. But PDM is a great solution for those questions. We can save templates, we can save custom properties, part files, whatever it is, we can save them on PDM, and then you're always working local.
Okay, so PDM might be a good one. We got time for one more question, then we're going to have to end. So why don't you take this last one?
Yeah, it says, does saving a subassembly as a part file help performance? I would say yes and no. Majority of people I would say yes, because you're taking a subassembly that might have mates to it and you're changing it into one rigid body. Now, typically when you have a subassembly, it's already a rigid body, so it's barely worse than a part file on itself. But yeah, that could definitely be a helpful thing. Just know that part files in assemblies, the more faces, the more little tiny slivers of faces they have, the slower your graphics performance is going to be. So that's not an end-all solution to having a big assembly, but it's definitely a factor. It can help.
Yeah, I'm seeing a couple more questions coming in, but we're running out of time, and I don't want to go over, and it looks like some of the other questions might be slightly duplicate. Why don't we do this? We're going to make sure, audience, that every question that's been asked will get answered in writing, and we'll send that link out to you. So we're going to have to close. And Justin, thank you very much. This was an awesome event, and I think our customers really learned a lot about how they can improve performance. So everyone, thank you from 3D Vision Technologies for joining our 10-4 Tech Talk. See us next month, same time, the fourth Thursday at 10 o'clock. And our topic is going to be on printing, 3D printing. So I appreciate it very much. Thank you and have a productive day.